Welcome all for this session. Today we are going to discuss about multiple integrals. So multiple integrals, I am going to teach double integral. One of the most application of double integral is finding the area of the given region. So first we'll see the multiple integral. So we are going to discuss about double integral today. First we'll discuss about the evaluation of double integral. Evaluation of double integral. Evaluation of double integral. First, we'll discuss about the limits. So the evaluation of double integral depends on the nature of the curves binding the region R. Let the region R bounded by the curves x equal to x1, x equal to x2, and y is equal to y1, y is equal to y2. Now there are three cases. We'll discuss about three cases here. Case 1. If x has variable limits, and y has constant limits, Let us consider the double integral f of x comma y. So here x has variable limits, so the inner integral must be in terms of x dx, then outer integral with respect to y, so dy. So here x has variable limits, so consider the variable limits as here the inner integral with respect to x. Here x has the variable limits, so consider the limit as the lower limit is equal to x1 is equal to, if the inner integral with respect to x means the limit must be in terms of y, function of y. So x1 equal to pi 1 of y. Then the upper limit is x2, which is equal to pi 2 of y. So the limit of x must be a function of y only. Then here the y limit are constant. Take the constant limit as the lower limit is y1, upper limit is y2. Now how to find the limits of this variable limit? How to find x limit here? So here draw this diagram. This is the x-axis and y-axis. To find x limit, we have to draw a horizontal strip. So take this as pi 1 of y, pi 2 of y. x1 is the lower limit, x2 is the upper limit. So by drawing a horizontal strip, we can find the x limit. So see here, the left end of this horizontal strip will give the lower limit. The right end of the horizontal strip will give the upper limit. So to find the lower limit, how to take the starting point of the horizontal strip. To find the upper limit, we have to take the ending point of the horizontal strip. So from this point, we can get the inner integral limits, so x limit. So here, to find the outer integral limit, y limit is a constant limit. So in y axis, we have to take minimum value and maximum value. So the outer integral limit always constant. Inner integral limit is with respect to x means the limit must be in terms of y. Then here we have to integrate, first we have to integrate with respect to x. After integrating, then we will integrate with respect to y. So this is case 1. Now we will move on to case 2. In case 2, x limits are constant, but here y limits are variables. So y has variable limits. Y has variable limits. Y limits are variables. And here x limits are constant. X limits are constants. So in this case, how to find the limits? So consider this double integral f of x comma y. Here y limits are variable, so the inner integral must be with respect to y dy. Outer integral limits, x limits are constant, so the outer integral with respect to x. And here the inner integral limit with respect to y, so the y limits are in terms of, it must be a function of x. So pi 1 of x is the lower limit. Then inner integral limit, this is the upper limit, it's denoted by pi 2 of x. So the limit inner integral with respect to y means the limit must be in terms of x. Here the outer integral limit must be a constant limit. So here to find y limit, what you have to do? So by drawing a vertical strip, we can find the y limit. So to find y limit, always we will draw a vertical strip. Vertical strip. So draw a vertical strip. So this lower limit, this bottom end of the vertical strip will give the lower limit. The top end of the vertical strip will give the upper limit. So here we will be getting the lower limit y1 pi 1 of x. Here we will give the upper limit y2, which is equal to pi 2 of x. Then here dx, the x limit must be a constant limit. So to evaluate this integral, first we will evaluate the integral with respect to y. So when you integrate with respect to y, treating x as a constant term. Then after that you have to integrate with respect to x. So this is a case 2. Then now we will move on to case 3. Case 3. In case 3, both the limits are constant. X and y limits are constants. X and y limits are constants. X and y limits are constant. If x and y limits are, both limits are constants, then in this case we can evaluate the given integral like this. Double integral f of x comma y. You can take the order as dx dy, or you can use this order, double integral f of x comma y dy dx. So in both the cases you will getting the same answer only. So if the limits are constant, then either you can use this or this. Okay. Then now we'll solve some problems. So first I am going to evaluate one double integral. So consider this problem, evaluate double integral xy into x plus y, xy into x plus y dx dy over the region bounded by dx dy over the region bounded by y is equal to x square and y is equal to x. Evaluate the double integral xy into x plus y dx dy over the region bounded by y is equal to x square and y is equal to x. So in this problem they given the region of integration bounded by one curve y is equal to x is actually is a parabola, and they given one straight line y is equal to x. So to evaluate this double integral, first we need to find the limits. So first what we are doing, Here the region of integration bounded by region of integration is bounded by the line curve y is equal to x square and the line y is equal to x. So first let us draw the diagram using the given line and the curve. First we have to draw the diagram. So draw the diagram, consider x-axis and y-axis. First let us draw the straight line. So y is equal to x is the straight line, equation of straight line. So how to draw the straight line? To draw any straight line we need at least 2 points. At least minimum 2 points we need to draw any straight line. So find out the points. So put x equal to 0, then find the value of y. So put x0 here in the equation, so you'll be getting y is equal to 0. So if x is 0, y is also 0. So we are getting the point as a 0, 0. Now we need one more point, so put x equal to 1. If x equal to 1, find the value of y. Y is also 1. So here we are getting the point as 1, 1. So now by joining these 2 points, we will be getting a straight line. So 0, 0, this point will be this origin, and take the point 1, 1. The point 1, 1 will be here. Now by joining these 2 points, we will be getting a line. So this is the straight line, y is equal to x. Okay, now let us draw the curve, parabola. This is a parabola actually. To draw any curve, we need minimum 3 points. So to draw this curve, it's a parabola, we are finding 3 points. So to find out the points, always we'll start from origin. So here put y is equal to 0. If y is equal to 0, then find out x. X is also 0. So we are getting the point as 0, 0. Now we need 2 more points. For that, put different value for y. What is the next value? Put y is equal to 1. If y is equal to 1, then find the value of x now. So we are getting x square is equal to 1. So which implies we are getting x equal to plus or minus 1. So by using these values, we are getting 2 points here. For x, we are getting 2 values, 1 and minus 1. For y, we are getting only one value, 1. So the points are 1, 1, minus 1, 1. So if x equal to 1, then y 1. If x equal to minus 1, then y is also 1. So now we have 3 points here, 0, 0, 1, 1 and minus 1, 1. So by joining these 3 points, we will be getting the curve, parabola. So already there is 0, 0. So this point will be 0, 0. Now 1, 1. Already the 1, 1 point is there. Then we have one more point, minus 1, 1. Minus 1, 1 will be here. This point will be minus 1, 1. So now by joining these 3 points, 1, 1, minus 1, 1 and 0, 0. Joining these 3 points, we will be getting the parabola. So by joining these 3 points, we will be getting the parabola y is equal to x square. Okay. So now we'll shade the region of integration. Here the region is between the lines and the curve. The region is bounded by the line and the curve. So this will be the region of integration. Okay. So now we'll find the limit now. So consider the integral. So here the integral I is equal to double integral xy into x plus y dx dy. Here the inner integral with respect to x. So if the inner integral with respect to x, now we have to find the x limit. So to find x limit, always draw a horizontal strip in the region of integration, the shaded part. Draw a horizontal strip. So the left end will give the lower limit and the right end will give the upper limit. So the left end touches the line y is equal to x. The equation of line is y is equal to x. So by using the equation of this line, find the value of x. So along this line, what is the value of x? We are finding x limit only. So the value of x is y, because the equation is y is equal to x. So x equal to y. So the value of x is y. So the lower limit of x is y. Then the right end of the horizontal strip will give the upper limit. The right end touches the curve parabola y is equal to x square. So by using this equation, find the value of x. So already we know that the equation of parabola is x square is equal to y. But we need to find only x limit, right? So find out x. X square is equal to y. So what is x? Plus or minus root y. But this our region is in the first quadrant. So in the first quadrant all the values are positive. So take only the positive value. So x equal to root y. So this will be the upper limit, root y. So y to root y. So the left end of the horizontal strip will give the lower limit. The right end of the horizontal strip will give the upper limit. So we got the inner integral limits. Then we have to find the outer integral limit. The outer integral with respect to y. So to find y limit, what you have to do? In the region of integration, this is the region, the shaded part. Take the minimum point and the maximum point. The region is varies from origin to this point. This is the maximum point. So in the minimum point, this is the origin. At this origin, what is the value of y? Because we are finding the only y limit. So at the origin, the value of y is 0. So start from 0. This is the lower limit. And the maximum, this is the maximum point. So at this point, what is the value of y? So from the point itself, we can know that the y value is 1. So upper limit is 1. So like this, we have to find the limits. Now, by evaluating this integral, we will get the answer. So how to evaluate? So to evaluate this integral, so the given integral is double integral xy into x plus y dx dy. The inner integral limits, already we got the limits, so y to root y. Then what is the outer integral limit? 0 to 1 y limit. Okay. Now we will evaluate this integral. How to evaluate? First we have to evaluate this inner integral. First we have to do the inner integration. Okay, so here the inner integral with respect to x. So to find how to integrate with respect to x, when you integrate with respect to x, we have to treat the y term as a constant term. Okay, so first we will simplify the given function, integral 0 to 1, integral y to root y. The outside there is xy, multiply xy inside, so we will be getting what? X square into y plus x into y square dx dy, x square y plus x into y square dx dy, xy into x square y. Then multiply xy with the second term, so we will be getting x into y square dx dy. So first we will integrate with respect to x. So to integrate with respect to x, treating y as a constant term. So integral 0 to 1, this is the outer integral limit. Keep the outer integral limit as it is. Now we will integrate the first term, x square into y. Here y is a constant term, so we will integrate only x square. Keep the constant as it is. Okay. Integrate only the variable, x square is a variable. So integration of x square with respect to x cube by 3. Integration of x square is x cube by 3. Here y is a constant term, so keep the constant as it is. Then plus in the second term, when you integrate this with respect to x, integration of x is x square by 2. Here y square is constant, keep the constant as it is. Now we will apply the limit. What is the limit here? The lower limit is y, the upper limit is root y. Now we'll substitute the outer integral with respect to y. So write dy as it is. Okay, now we'll integrate, we'll apply the limit now. What is upper limit here? Root y. So in the place of x, we have to replace root y. You have to replace, wherever you have x, you have to replace it by the upper limit, then by lower limit. Okay, first we'll apply the upper limit, root y. So we'll be getting what? X can be replaced by root y. So we'll be getting what? Root y the whole cube. Root y the whole cube into y divided by 3 plus, here this x is replaced by root y. So we'll be getting what? Root y the whole square into, already there is y square, divided by 2. So this is the upper limit. Then put minus sign, apply the lower limit. So now the lower limit is y. So replace x by y. So we'll be getting y cube. Y cube into y is y power 4. So you are getting y power 4 divided by 3. Then here replace x by y. So we'll be getting what? Y square into y square. You will be getting y power 4. Y power 4 divided by 2 into dy. So now we'll simplify the terms. So this becomes integral 0 to 1. So root y the whole cube is y into root y. Root y square is y. So y into root y, but already there is one y. So y square into root y. Y square into root y divided by 3 plus root y the whole square is y. Y into y square is y cube. So y cube by 2 minus, now we will simplify these two terms by taking LCM. It will become 6. 3 and 2, LCM is 6. So now take LCM and simplify. So we will be getting 2y power 4 plus 3y power 4. So we are getting 5y power 4 divided by 6 into dy. Again simplify this. So we are getting integral 0 to 1. Y square into root y is, root y, actually root y is y power 1 by 2. Y square into y power 1 by 2. Take LCM and simplify. You will be getting what? Y power 5 by 2. So y power 5 by 2 divided by 3 plus y cube by 2 minus 5y power 4 divided by 6 into dy. Now find the integration with respect to y. So y power 5 by 2 integration is y power 7 by 2. 5 by 2 plus 1 is 7 by 2. 7 by 2 by 7 by 2. In the denominator always there is 3. So write the 3 as it is. Then int plus y cube. Integration of y cube is y power 4 divided by 4. But already the denominator there is 2. 2 4s are 8. Then minus 5 into y power 4 integration y power 5 by 5. 5 into 6, 30. So 5 into y power 5 divided by 30. Now apply the limit. What is the limit here? Limit varies from 0 to 1. So first we'll replace the upper limit. So the first term becomes, replace y by 1 now. So 1 power 7 by 2 becomes 1. 1 per anything is 1 only, right? So here we are getting 7 by 2 into 3. So this 2 will go to numerator. So we'll be getting 2 by 21. Then y power 4, replace y by 1. So we'll be getting what? 1 by 8. Here replace y by 1. So we are getting minus 5 by 30. This 5 and 30 get cancelled. 6. We are getting minus 1 by 6. Minus 1 by 6. So here the lower limit 0. So now when you apply the lower limit, this becomes 0. So apply only the upper limit. So we are getting 2 by 21 plus 1 by 8 minus 1 by 6. Take LCM and simplify. 21, 8, 6. The LCM is, when you take LCM, you will be getting 168. Okay. Then, so multiply 20 to get 168, multiply 21 by 8. So we'll be getting 2 8s are 16. Here we are getting 21. Here we are getting 28. So 16 plus 21 minus 28. So when you simplify, you are getting 16 plus 21 is 37 minus 28 divided by 168. So after simplification, we are getting 9 by 168. So we can simplify this by 3. So 3 by 56. So this is the final answer. So I think everybody understood this problem. So we'll do one more problem in this same topic. Second problem, evaluate double integral. We'll do one more problem in the same topic. Evaluate double integral xy into dx dy. Xy into dx dy taken over the positive quadrant of positive quadrant of the ellipse, x square by a square plus y square by b square equal to 1. So evaluate double integral xy dx dy taken over the positive quadrant of the ellipse x square by a square plus y square by b square equal to 1. So now to evaluate this, first we'll find the limits. To find the limits, first let us draw the diagram. So consider x-axis and y-axis. So x-axis and y-axis. So here the region is bounded by ellipse. So the ellipse equation, directly we can draw the ellipse. This ellipse. So mark the points now. This point will be a comma 0. This point will be minus a comma 0. And this point will be 0 comma b. This will be 0 comma minus b. But here we are taking only our region is only the positive quadrant of the ellipse. So positive quadrant means that will be the first quadrant. So only the first quadrant is the region of the integration. So shades only the first quadrant, the positive quadrant, that means the first quadrant. So this is the region of integration. Now let us find the limit. So the given integral I is equal to double integral xy into dx dy. Here the inner integral with respect to x and the outer integral with respect to y. So to find x limit, the inner integral with respect to x, so we have to find the x limits first. So to find x limit, we'll draw a horizontal strip in the region of integration. So draw a horizontal strip. So in the horizontal strip, the left end will give the lower limit and the right end will give the upper limit. So here we'll find the limit now, xy into dx dy. So to find the x limit, the horizontal strip, actually this is the x-axis, the equation of x-axis y is equal to 0, and this line, this is the y-axis actually, the equation of y-axis x equal to 0. So now the left end touches the line y-axis. So what is the equation of y-axis? X equal to 0. So along this y-axis the value of x equal to 0. So the lower limit will become 0. Then the upper limit, to find the upper limit, the right end touches the curve, ellipse curve. So from the equation of this ellipse, find the value of x, because we are finding x limit. So the equation of ellipse is x square by a square plus y square by b square equal to 1. So here we are finding the x limit. So find out x square by a square equal to 1 minus y square by b square. So this will become x square is equal to a square into b square minus y square divided by b square. But we need only x, so find out x taking the square root. So we will be getting plus or minus a by b into root of b square minus y square. But here this quadrant is a positive quadrant. Our region is in the positive quadrant, so we'll take only the positive value. So the upper limit is a by b into root of b square minus y square. Then the inner integral, the outer integral always constant. So to find y limit, what we are doing, in y axis, the minimum point, we have to take the maximum point. So y axis starts from origin, so the lower limit of y is 0 and the upper limit of y is, so here the maximum point is this point, this is the maximum point 0 comma b. So at this point what is the value of y? The value of y is b, so the upper limit is b. Now by evaluating this we will get the answer. So how to evaluate this? So to evaluate, first let us integrate the inner integral. So here the inner integral with respect to x. So to find x limit, treating y as a constant term. So what we are doing here, y is a constant term, keep the constant as it is. So we will be getting what? 0 to b, keep the outer integral as it is. We will integrate the inner integral. Here y is constant, keep y is as it is, and integration of x is x square by 2. X square by 2. Now here the limit varies from 0 to a by b into root of b square minus y square. Here the outer integral with respect to y, so write dy as it is. Okay, now we will apply the limit now. So which is equal to integral 0 to b y into, here 1 by 2 is constant, take it out. So we will replace x by the upper limit. So instead of x square, we have to, instead of x we have to replace a by b into root of b square minus y square. But here there is square. So when you take square, this root will become, so this will become a square by b square into b square minus y square. Then now we have to apply the lower limit. To apply the lower limit, what you have to do, here the lower limit is 0. So if you apply the lower limit, it will become 0. So leave that. Okay. Now we have to integrate this with respect to y. Here 1 by 2 is constant. So keep this 1 by 2 outside. Now we have to integrate with respect to y. Before integrating, and here a square by b square is also constant, so take it out. This a square by b square is also constant, so take it out. So now inside we have y into b square minus y square. The multiply y here, so we'll be getting what? Y into b square minus y into y square. Y into y square becomes y cube. So now we'll integrate this 0 to b, limit, lower limit is 0, upper limit is b into dy. Okay, now we'll integrate this. So outside there is a square by 2b square. It's a constant term, keep the constant as it is. Now we'll integrate yb square. Here b square is constant, so b square into integration of y is y square by 2. Then we'll integrate y cube. Y cube integration is y power 4 divided by 4. Now apply the limit. What is the limit here? 0 to b. So apply the upper limit first, then we'll apply the lower limit. So first let us replace y by the upper limit b. So we'll getting the answer as a square by 2b square. When you apply the limit, you'll be getting what? Upper limit is b. So replace y by b. So it will become b square. Already there is b square. So b square into b square is b power 4. So b power 4 divided by 2 minus. Now here replace y by b. So you'll be getting what? B power 4 divided by 4. B power 4 by 2. B power 4 by 4. Now here the lower limit becomes 0. When you apply, when you replace y by 0, this will become 0. So leave that. Okay. So now take LCM and simplify. So this will become a square by 2b square into 2 and 4. The LCM of 2 and 4 is 4. So multiply this by 2. So you will be getting 2b power 4 minus b power 4. 2b power 4 minus b power 4 is b power 4. So we are getting b power 4 divided by 4. B power 4 divided by 4. Now simplify this and get the final answer. So here we are getting this one, b square and b square get cancelled. So final answer is a square b square divided by 2 4s are 8. So this will be the final answer. So evaluation of for the evaluation of double integral, first we'll have to find the limits using the given region. After finding the limits, by using the limit we have to find the integration. So like this we'll evaluate any given double integral. Now let us see one more concept in this multiple integrals. It's called change of order of integration. So how to change the order of integration, then evaluate. Okay. So let us see one more topic in the same multiple integrals concept. So the topic is called change of order of integration. Change of order of integration. Change of order of integration. Okay. So we'll solve one problem using this method, change of order of integration method. So I'll take one problem using evaluate double integral 0 to a y to a, 0 to a y to a, x into dx dy, x into dx dy divided by x square plus y square, x square plus y square, x square plus y square. So integral double integral 0 to a y to a x into dx dy divided by x square plus y square. Evaluate this using change of order of integration. Using change of order of integration. Using change of order of integration. Okay. So here we are going to do this step by step. First, consider the given limits. So first, before taking the limits, we have to check the order of the integration. We have to check the given order of integration is correct or not. We have to check the order of the integration. See here, in the given integral, the inner integral with respect to x and the outer integral with respect to y. If the inner integral with respect to x, then inner integral with respect to x, then we have to see the limit in terms of y. So if the inner integral with respect to x, the limit must be in terms of y. So here we have only y, the limit, inner integral limit in terms of y only. So therefore the order of the integral is correct only. Okay, so now we'll proceed with the same limit. First we have to write the given limits. Step 1. This is step 1. In step 1 we'll write the given limits. So here the given limits are x equal to y. This is the x limit, so we have to take x equal to y and x equal to a. Then the outer integral limit, this is the y limit actually, so we'll take this as y is equal to 0, y is equal to a. So this is step 1. In the step 1 we have to write the given limits. In the given integral, the given limits, that limits only you have to write in step 1. Step 2. Using the given limits, draw the diagram. This is step 2. Using the given limits. So in the given limits they given 4 lines. Actually all the limits are lines, straight lines only. So to draw a diagram we can use the given limits. So consider x-axis and y-axis. So in step 2 we'll draw the diagram using the given limits. So how to draw the diagram? First we'll take the first line. This is the equation of straight line x equal to y. So to draw this straight line we need minimum 2 points. So find out the points here. If x equal to 0, then find y, value of y. Y is also 0. Therefore here the point is 0, 0. So to draw a straight line we need minimum 2 points. So find out one more point. So for that put x equal to 1. If x equal to 1, what is the value of y? Y is also 1. So we are getting 1, 1. So now by joining these 2 points we'll getting the straight line 0, 0 and 1, 1. Or we can take if x is 0, y is 0, then if x equal to a, then we'll be getting y is equal to a, then the point is a, a. So this point is a, a. Okay, so this is a straight line y is equal to x or x equal to y. Now we'll draw the second line x equal to a. So x equal to a means this line is x equal to 0. Actually this is x equal to 0. So if x equal to 0, then what is x equal to a? This line is parallel to y axis. So this line is x equal to a. Then draw this y is equal to 0. Y is equal to 0 means this is the x axis. So this line is y equal to 0. Then to draw y is equal to a, y equal to a is parallel to this x axis. So this line is y is equal to a. Now we'll shade the region of integration. So the region of the integration is bounded by these 4 lines. What are the lines here? X equal to y. The region is bounded by 4 lines, x equal to y, x equal to y line, then x equal to a, the line x equal to a, and the line y is equal to 0, and the line y is equal to a. So the region of integration is this part. This is the lower part of the triangle. So this will be the region of integration. So in step 2 we'll draw the diagram. Now we'll move on to step 3. So in step 3 what you are going to do, we have to change the order of, because this topic is change the order of integration. So in step 3 we'll change the order. In step 3 we'll change the order of the integration. So if you change the order, the given order is actually, this is the given order is dx dy. This is the order of the given integration. So now we'll change this order. So now the order becomes dy dx, double integral x into dy dx, x by x square plus y square into dy dx. Okay, so after changing the order of integration, so in step 3 we'll change the order. change the order of integration. Order of integration. After changing the order of integration, step 4, we have to find the new limits. To find the new limits. New limits. So the given integral I is equal to, after changing the order, the integral becomes x by x square plus y square dy dx. So the diagram is like this. This is our region of integration. Okay, and this line is x equal to a, this line is x equal to y, this line is y is equal to 0. So how to find the y limit? So here the inner integral with respect to y. We are finding new limits, right? So to find new limits, first we have to find y limit. The inner integral with respect to y. So first find y limit. So to find y limit, draw a vertical strip. Draw a vertical strip in the region of integration. Draw a vertical strip. So in the vertical strip, the bottom end will give the lower limit and top end will give the upper limit. So the bottom end touches the x-axis. So the equation of x-axis is y equal to 0. So along x-axis the value of y equal to 0. The value of y is 0. So the y limit is 0 to, lower limit is 0, and the top end will give the upper limit. So the top end touches the line x equal to y. So along this line, what is the value of y? The value of y is x. So we are getting the limit as 0 to x. Limit as 0 to x. 0 to x. Next we have to find the x limit. The outer integral with respect to x. So find x limit. To find x limit is always constant. Outer integral limit always constant. So to find x limit, in x axis we have to take the minimum point and maximum point. So this x axis varies from origin 0 to this point. So at this point the value of x is a. So x limit is, we are getting the limit, x limit is 0 to a. Okay, so after finding the new limits, this is step 4. Then step 5 is evaluation of this double integral using the given using this new limits. So now we have to evaluate the integral, double integral x divided by x square plus y square into dy dx. So here the y limit is 0 to x, the x limit is 0 to a. Now we have to integrate this. Integral 0 to a, outer integral limit, keep the limit as it is. The inner integration with respect to y. So now we have to integrate this with respect to y. So how to integrate this with respect to y? So if you, when you integrate with respect to y, treating x as a constant term. So here x is constant, take it out. So now we have dy by x square plus y square. Here y is the variable. So now the integration formula, know the formula, integral dx by x square plus a square is equal to 1 by a tan inverse of x by a. This is the formula. So this formula only we are using here. So integral dx by x square plus a square means the formula is 1 by a tan inverse of x by a. But here we have the, here dy, instead of x we have dy y. So dy by y square plus, instead of a square we have x square here. This is a constant term actually. So by using this formula we will be getting 1 by a. here a in the place of a we have x. So we are getting 1 by x tan inverse of x by a. Here x is y, so y by x. Because here x is a constant term. Instead of a we have x here. So now the limit varies from 0 to x. The outer integral with respect to x. Keep this as it is. Okay, now this x and x get cancelled. So now we have tan inverse of y by x. Now apply the limit. The upper limit is x. So replace y by x. So we'll be getting 0 to a tan inverse of, apply the limit now, instead of y replace x, so we'll be getting x by x is 1, tan inverse of 1. Then when you apply the lower limit, instead of y replace 0, so you'll be getting tan inverse of 0. So when you apply the lower limit, you are getting tan inverse of 0. So tan inverse of 1 minus tan inverse of 0 into dx. So it is equal to integral 0 to a. Tan inverse of 1 is pi by 4. So in tan, for 1 only we are getting pi by 4. Tan inverse of 1 is pi by 4. Minus tan inverse of 0 is 0. So pi by 4 minus 0 into dx. So pi by 4 minus 0 is pi by 4. So integral 0 to a pi by 4 into dx. So pi by 4 is a constant term, so take it out. Pi by 4 into integral dx. Integral dx is x. Now apply the limit here. Here the limit, lower limit is 0, upper limit is a. So now apply the limit. Upper limit is a. So replace x by a first. So we'll be getting pi by 4 into a minus, apply the lower limit is 0. So we are getting pi a divided by 4. So this is the final answer. So for using this change of order of integration, easily we can evaluate any type of given integral. So here we are using some 5 steps. In step 1 you have to try the given limits. Step 2 you have to draw the diagram. In step 3 we will change the order of integration. Then in step 4 we are finding the new limits. After changing the order, the limit will differ, so we have to find the new limits. After that, using the new limits, how to evaluate the given integral. Okay, so now we'll do one more problem in the same concept, change of order of integration. Changing the order of integration, we'll do one more problem in the same concept. Changing the order of integration. Changing the order of integration, and hence evaluate double integral dy dx, inner integral limits of 0 to x, the outer integral limit 0 to 1. So by using the same concept, we'll evaluate this. So in step 1, first let us check the order of this integration. So here the inner integral with respect to y. The inner integral with respect to y, then the limit must be in terms of x. So the outer integral always constant. So here the limits are in the order of the integration is correct only, so we can proceed as it is. So now in step 1, first write down the given limits. Here, what are the given limits here? The inner integral with respect to y. So write down the given limits. In step 1, we'll write the given limits. So the inner integral with respect to y. So this is the y limit. So y is equal to 0. We will take that y is equal to x. Then here the outer integral is x only. So outer integral limits are x limits. So we'll take this as x equal to 0 and x equal to 1. Now in step 2 we'll draw the diagram. So by using the given limits, draw the diagram. Actually here they given 4 straight lines only. So by using all the 4 lines, draw the diagram. X-axis and y-axis. So here the line y is equal to 0. Y equal to 0 is the equation of x-axis, and x equal to 0 is the equation of y-axis. Y is equal to x is a line. We have to find the points 0, 0 and 1, 1. So this point will be 1, 1 and this point will be 0, 0. By joining these 3 points, we'll be getting the line y is equal to x. Then there is one more line, x equal to 1. So this line will be x equal to 1. So x equal to 1. Okay, now we'll shade the region of integration. The given line is bounded by y0, x0 and x equal to 1 and x equal to y. So we'll shade the region of integration. So this is the region of integration. Now we will find out the, after drawing the diagram, step 3. Step 3 is change the order. Changing the order of integration. So the given order is dy dx. After changing the order, change the order of integration. Now the given order becomes double integral dx dy. The given order is dy dx. After changing the order, this will become dx dy. So after changing the order, we have to find the new limits. So the new limits are, find the new limits now. So here the inner integral with respect to x. So we'll find the x limit first. To find x limit, draw a horizontal strip in the given region. Horizontal strip. Draw a horizontal strip in the given region. So here the left hand will give the lower limit, right hand will give the upper limit. So the left hand touches the line y is equal to x. So along this line y is equal to x, what is the value of x? X is equal to y. So the limits start from y. And the right end horizontal strip, right end of the horizontal strip touches the line x equal to 1. So along this line, what is the value of x? 1. Now we'll find the y limit. How to find y limit? To find y limit, here take the minimum point and maximum point. So this is the minimum point and this will be the maximum point. So at this point, what is the value of y? The value of y is 0. And this is the maximum point. At this point, the value of y is 1. So 0 to 1. So now the x limit is y to 1, y limit is 0 to 1. So now by using the limit, we can evaluate the integral. Step 5, evaluation. Evaluation of given the integral. Evaluation of the integral. So after changing the order becomes dx dy. So now the limits becomes inner integral with respect to x. X limits are y, lower limit is y, upper limit is 1. Y limit is 0 to 1. It's a constant limit. Now we'll integrate this. 0 to 1, y to 1, dx dy. 0 to 1, y to 1, dx dy. 0 to 1, y to 1, dx dy. So we'll evaluate this integral now. So this becomes inner integral with respect to x here. So when you integrate with respect to x, integral dx is x. So we will be getting x here. Now apply the limit. Here the lower limit is y, upper limit is 1. So upper limit is 1. So replace x by 1. So we'll be getting 1. 1 minus, lower limit is y. So we are getting 1 minus y into dy. Now we will find the integration with respect to y. Here 1 is a constant term, integration of 1 is y, integration of y is y square by 2. Limit varies from 0 to 1. Now the upper limit is 1, so 1 minus 1 by 2. Lower limit is 0, so this will become for low. If when you apply lower limit, both the terms are 0, so leave that. Now we'll simplify this. 1 minus 1 by 2 is 1 by 2. So this is the answer for this problem. So I hope everyone understood this concept, change of order and evaluation of any type of given integral using the given region, and also changing the order of integration, how to evaluate a given double integral. So thank you students for listening to this lecture, and we'll continue with one more topic in the next session. Thank you all.